When you first start out estimating uncertainties in the lower six, your first few measurements will probably be single measurements with analogue measuring instruments. So remember, that means a measuring instrument with a scale such as a ruler or an analogue voltmeter. We do, however, include stopwatches in this group. We estimate the uncertainty as simply plus or minus the smallest amount that can be measured on that scale, and this is called the graduation. So for using the top scale on the ruler there, the millimetre scale, we would estimate the absolute uncertainty of a measurement as plus or minus a millimetre. For the voltmeter, if we use the bottom scale, we would have plus or minus 0.1 volts, and if we use the top scale, plus or minus 0.5 volts there. And for the stopwatch, we typically take human reaction times to be 1/10 of a second, and we treat that as the graduation. So we estimate the absolute uncertainty of a stopwatch measurement typically as plus or minus 0.1 seconds. Why is that? The justification goes that when you use a scale to measure something, it involves making two judgments, one for the start and one for the end. Here, I would judge the left side of the rectangle to be at 10 millimetres and the right side at 50 millimetres. But what are the uncertainties of these judgments? Well, the left side could be as low as 9.5 millimetres and I'd still judge it to be at 10, or it could be as high as 10.5 millimetres. So we could estimate the uncertainty as plus or minus half a millimetre. The same argument can be made for the other side. Now, what is the width of the rectangle? Well, max minus min gives 41 millimetres and min minus max gives 39 millimetres. And so this is why we say that the width of our rectangle is 40 plus or minus 1 millimetre. An example where we're perhaps more conscious of making these two judgments is measuring the thickness of something with a micrometer. Here we always need to check that the micrometer reads 0 when the jaws are completely closed. If it doesn't, we have what's called a zero error. Because we make that first judgment and then also the second judgment, we again estimate the uncertainty as plus or minus 1 graduation, which in this case is 1/100th of a millimetre. Newton meters are really nice for introducing this method in class because you can measure the mass or weight of the same object with a variety of Newton meters, and they will have different sized graduations, and so the uncertainties will be different for the different measurements. And this can give you the opportunity to make the point about choosing the best measuring instrument for the job, namely the one that's going to give you the best accuracy and the lowest uncertainty. Measurements that involve two judgments like these are called double-ended measurements, and you can see how stopwatches fall into this category. You judge when to start the stopwatch and you judge when to stop it. There are just a few measurements you might make at A-level that do not fall into this category. When you use a measuring cylinder to measure volume, for example, you can't check that the bottom of the cylinder is at 0 on the scale before you start. With a thermometer, you can't check that it reads 0 at absolute 0, and with a pressure gauge, you can't check that it reads 0 at absolute 0 pressure. These measurements are therefore called single-ended measurements, and the absolute uncertainty should, by our previous argument, be estimated at plus or minus half a graduation. However, remember the previous rule that an absolute uncertainty cannot have more decimal places than the value itself. And what this means is that even if you do estimate the absolute uncertainty as plus or minus half a graduation, you end up rounding it up to plus or minus 1 graduation anyway, virtually all of the time. So for this reason, exam boards are perfectly happy to ignore the distinction between double and single-ended measurements, and we can all simply estimate all analogue single measurements as plus or minus a graduation. If you're finding these videos useful, please subscribe, and don't forget to check out our resources on the website and follow Learning Dojo on Twitter.